where I want you to be at in your packet. So it looks like this. It's the domain and range practice that we ended up on. Does everybody see that? Can someone unmute and let me know? And can you hear me okay? Can you hear me okay? And can you see this? Can someone just let me know, please? Okay, thank you very much. I appreciate that. So I'm just going to do the top 4. This is, I did not have this in the videos, and I just want to make sure that we practice one of each kind. So I'm going to do these first 4 here. So I'm starting off with something that's pretty basic and then getting a little more, and for radicals. So the first one is, it's d of y equals y plus 3. I graph that on my calculator. I have to use an x. And when I do, I get a line that crosses at 3. So there's my nice little sketch. It's bigger than my pinky. I have x, y there. You guys have some space on the side that I don't have. Well, the first thing when I look at this, I said, wait a minute. There's no fractions, no radicals. I'm not worried at all. If I'm not worried, that means I don't have to restrict what goes in my domain. So my domain is negative infinity to positive infinity, which is all real numbers. That means I can put negatives, positives, zeros in there. If I squish this to the x-axis, you'll see that it goes forever. There's no restriction. Also, if I look at my graph and I squish this to the y-axis, you'll see it goes forever up and down to positive and negative infinity. So here, the range is actually the same. It means that I can put any number I want in there, and out is going to come any number, and there's no restriction on it. So this is all real numbers. That's the best kind. I'm not worried at all. Don't have to do any algebra. I can just look at the graph and say that's the case. Now I'm going to look at number 2. Number 2, again, I see no fractions or radicals. So when I sketch it, it looks like this parabola here. Here's number 2. And I actually even did the vertex on my calculator because I need to know that, because the lowest that parabola goes is -1, -8, and that's my y value that I need to know because it's the lowest y that I have. So first of all, I'm not worried. So there's no restriction. So again, my domain is negative infinity to positive infinity. There's really no algebra to do because there's nothing that I have to restrict it from. There's no radical and there's no fractions. Okay? Because I graph this, and if I squish this to the y-axis, you'd see the lowest y I have is -8, and the vertex -1, -8 is included in the graph, so my range would go from -8 all the way to positive infinity, and I never reach it there. So there's my range. So I started with, I'm not worried at all. My domain and range are all real numbers. Number 2 is, I'm not worried about what goes in my function, but the only thing that comes out is -8 and higher for my y's. Okay? Now I look at 3 and 4 and see that they're radicals. So I know I have to do algebra for this one, and I have to do algebra for this one. And I will require you next week when you take your quiz is to show me how you came up with it. So I look at number 3. I graphed number 3. So as you can see the little sketch down here, X and Y, and then it looks like it starts at 4 and it goes to the right, which looks like a radical graph. Okay, so I'm going to do algebra for these two, and I'm going to kind of stick it in here in between the functions. So I hope this doesn't get too messy for you. So I'm going to do the algebra right underneath number 3 to show you how that 4 came about and to make sure that I'm doing the domain right. So I know I have to do algebra. So I take what's underneath the radical, and it has to be greater than or equal to 0, because if you have a a even number radical, you cannot have a negative underneath there. So I'm basically saying I can only put numbers in that make my graph 0 or more because I can't have negatives. So then when I add 8 to both sides, I get 2n is greater than or equal to 8. Divide by 2, n is greater than or equal to 4. And I'm really happy because when I graph this, it looks like it starts at 4 and gets larger. So here's my x-axis. It goes to infinity. My domain includes 4 and goes all the way to the right to positive infinity, but I never really get there. Or if you need to, you can squish it to the x-axis to make sure that you look at it that way. Now, this is what confuses people, because if you think about it, this is the 0.40. The lowest y I have is a 0. And it should be because I can't go, I can't have a negative number, so the lowest y I'm going to have is 0, and it's included, so my range is going to be 0 all the way to positive infinity, but I never really get there. And you'll notice with radical functions that your range is usually 0 to infinity because it doesn't even exist down in quadrants 3 and 4. Okay, let's try another radical. Here's number 4. I kind of did a sketch. I'm like running out of room here. It's this one down here. And I did my X and Y axis, and it looks like this. Looks like it starts at 3 and goes to the left. Okay, so I know there's algebra to do. I'm going to do the algebra to see if that 3 shows up anywhere. So I take what's underneath my radical, say it has to be greater than or equal to 0. Now, I know you guys know to subtract 9, divide by 3, flip your arrow, but you know what's much easier is to move the 3t on the other side and make it positive. Then you don't have to worry about that. And then I divide by 3, I get 3, okay, it's greater than or equal to t. And if you look at the larger number is by the 3, the crocodile eats the 3. So I'm just going to write it this way, which is the same thing. As long as the little point is the less than part is to the t and the greater than part is next to the 3. So both of those are the same. And I'm like, that's true. It looks like it's 3 and everything less, but you got to be careful. Remember, that's negative infinity, and you have to do it the way the number line goes. So my domain is going to go from negative infinity, come all the way up to 3 and include it. You have to write it that way. You can't flip those spots. So you're going left to right, just like a number line. Okay. The range, my lowest y, if you look at this is a 0.30. My lowest y is a 0, and then it doesn't even exist in quadrants 3 and 4. So my range is going to be the same as above 0 all the way to positive infinity. So what I just did was practice one that starts with no restrictions, then some with no restrictions putting in for domain, but what comes out is -8 and greater. And then I have radicals where there's restrictions that I cannot even put certain numbers in there because the graph doesn't exist over on the other part, and then that affects my domain, and then I have to check my range to see what comes out. Okay, so there's some practice there on that one. Now, I need to have you next, please go to the front of your packet and find the in-class warm-up, and it's number 6. I have done a video for A, B, and C, okay? So I would like to go to D. So I want everybody to come here and let me find it. Did I get rid of it already? Nope, it's right here. So here's where it is. So I already did A, B, C. So I want you to, this is in the front of your packet, come down to D, all right? And I'd like to do D with you. So D is kind of weird because I have an x squared underneath the radical, and there's a radical, so I know I've got to do something. So the first thing I did was kind of graph this. So I'm going to make this bigger than my pinky, x, y, and then I graphed it. I'm going to set this all up so I can do my domain and my range. So I know there's algebra that I have to do, I have to show, okay? So I graphed it, so I have it here already. So I'm going to find my calculator, and I'm going to go over, okay, whoops, and I'm going to go over to this graph. I think it was my first one. Yep. So when I graph this, look at it. It looks kind of weird. It looks like the graph is right here. Looks like a -2 right here, and it's 1, 2, 3. It looks like a 3 here, and then it goes all the way to the right, have an arrow, comes over here on the left, has an arrow. And it looks like it doesn't even exist in the middle. And it doesn't exist down in quadrants 3 or 4. So that's kind of interesting. So I went over and I actually sketched this graph on my sketch here. So I put -2 here, and I'm going to go like this. And then I've got 3 here, and I'm going to go like this. Now, I have to show algebra. So this keeps telling me, take what's underneath the radical, has to be greater than or equal to 0. Now, I don't know if you guys remembered, but in Algebra 2, when you did this, when you had a greater than sign, you had stuff that was on the left and on the right and not in the middle. But if you forgot that, this is what you can do. Hang on with that greater than or equal to. Let's just do the equal to part. So if I did x squared minus x minus 6 equals 0, I'm going to try to factor that and just do equal 0, and then we'll go back and fix that. So this is an x and an x, and I know it's got to be a minus 3 and a plus 2 when I factor to get that negative x in the middle. I do a big T, x minus 3 equals 0, x equals 3. Oh, that makes me happy because that's what I have. X plus 2 equals 0, x equals negative 2. Now, I'm modeling to you exactly the work that you need to show. Please don't skip any of these steps. So here's the thing. How do I write this? Well, it looks like my graph is going to the right, so it looks like x is greater than or equal to 3. And then it's going to the left, so this is positive infinity, negative infinity. So this looks like it's x is less than or equal to negative 2. And that's what we had to do when we actually did these types of functions in Algebra 2, is when it's greater than, I always tell the kids, thumbs out, you're going to go to the right or to the left. But now we have to write this as our domain, all right? So I'm going to put this right in here. My domain, so you go left to right, goes from negative infinity all the way up to negative 2, and it includes it, so I have a bracket, in union with bracket 3 all the way to positive infinity, parentheses. So literally I have this huge gap in the middle, but I can have all the numbers left of negative 2 and all the numbers right of negative 3 go into my graph, but I can't have anything in the middle because it doesn't exist. Again, with the range, I look at this. This is a 0.30. This is a -20. My lowest y is a 0. It doesn't exist in the quadrants 3 and 4. So my range would be 0 to infinity. And I have it open at the end as a parentheses because you never really get there. So I wanted to show you kind of a weird one with a radical. So you can do things like this and it shouldn't bother you that much because you can do the algebra, you can look at your graph, and then you can do your domain and range. All right. So I have a few minutes here because I want to make sure you have to do for tomorrow domain and range lab number 2. So if you want to find that for me, please, this is what it looks like. So yesterday I assigned domain and range, Monday I assigned domain and range lab number 1. That's due today. So if you haven't finished that, you really need to finish that. And today I'm assigning domain and range lab number 2, so that's really due for tomorrow. So we're going to practice this again. The other thing I want to remind you guys is I put all the solutions up because I only see you once a week, but doesn't mean that you should have it open. I'm always suspect when I check a student's homework and there's not one eraser mark. You should be doing this and making mistakes and fixing it so that when you take the domain and range quiz next week, you really get it. I don't care if you check the homework, but please don't have it up while you're doing this, okay? So if you want to find this in the back of your packet, this is what's due for tomorrow, some more practice. So I'm going to go to number 4 and to practice this one because I didn't do a fraction. So here's number 4. I'm going to practice a fraction again. So you set this up just like I always do, domain and range. And over here, I'm going to do a nice sketch on my function that's bigger than my pinky. So here's x and y. I actually graphed this one here, and it looks like there's a hole right here because the function comes like all the way over here. So this is a nice sketch, and then it comes down this way here. And I looked at my calculator, it looks like there's a 4 there. So there's my sketch. I'm modeling to you what a good sketch is. So it's a fraction. I have algebra to do. When you do a fraction, you basically are telling me what you can't have, and I know I can't have a 0 in the denominator, so I actually take the denominator and say it cannot be 0. And now I do the algebra. Take the square root. I have x minus 4 can't be 0. Add 4 to both sides, x can't be 4. And that makes me happy because look where there's a vertical asymptote right there at 4 where the graph doesn't exist. There's a hole there. Now, when you write the domain, remember you're coming from negative infinity all the way to positive infinity. So you're coming from the left all the way up to 4, jumping over 4 and going there, but you have to go right up to it. So I'm going to write it like this. I'm coming from negative infinity all the way up to 4. I can't include it because that's where the hole is, in union with 4 to infinity. And remember, I told you, you can't put a bracket there because the 4 would make a 0. And the other thing is you can't use a 3 or something because there's millions of numbers between 3 and 4. So you have to go all the way up to 4, but not include it. So that's your hole is right there in the middle. Now, if you look at your graph, it looks like it's getting closer and closer to the x-axis, but it doesn't really touch it. So my range, and it doesn't exist in quadrants 3 and 4, my range is going to go, the lowest it looks like it's going is 0, but it doesn't look like it's touching it. So it's 0 all the way up to positive infinity. And I'm going to use parentheses because I'm never going to get to positive infinity, which is up here. And the 0, it never is touching. So I did one of the practice ones. Let me see. I have time for one more weird one. So how about we go to, on this lab, 14. So if everybody wants to go to 14, and then you just need to finish this for tomorrow. So here's 14 right here. Okay. So I have this cool theater. I like to go watch movies. It's called Trinomial Theater. It's my favorite. And it seats 700 people. Good to know. For any particular show, the amount of money the theater creates is a function of the number of people, n. So I'm going to use m for money, and this is the number of people. And now watch what I just said. The amount of money the theater creates is a function of the number of people. So I'm going to say that in math. The amount of money the theater creates is a function of the number of people. I just made a math sentence out of there. This is money. This is number of people. If I make a point out of it, it would be NM, number of people and money. So this is like my X and Y. So my N is my domain. My money is my range. That's literally how you get this set up, okay? So let's do the domain. Let's do the range. The domain we just noticed is the number of people. So I have to figure out, okay, I'm talking the number of people in the movie theater. And remember, this is a movie theater. So I can't have negative people in there, but I could have nobody come to the movie theater, a 0. I could have nobody show up. I've been at showings with my husband where we're the only 2 people in there, okay? But then what's the most I can have in that movie theater? Well, they said it seats 700. So I can't put 701 or that one person wouldn't have a seat or it wouldn't be for the code for the fire code. So the highest I can go in that theater is 700, and it's including 700. So that's my domain. That's how many people can go into that movie theater. Okay. Now my range, we already said, was the amount of money you make. So I look above and say, okay, if nobody goes in the movie theater, I'm not going to make any money. So the lowest I can make is $0. But then they said the cost of each ticket is $10.50. So I'm thinking, well, what's the most amount of money I can make? Well, the most amount of money I can make is if I fill the theater with 700 people, they each pay $10.50 a ticket. And when I do that, I get $7,350 in my movie theater. So that is actually my range. So when you have like a word problem like this, usually you can't go lower than 0 because it doesn't make sense. So my domain is the number of people in my movie theater is from 0 to nobody showing up all the way up to 700 if it's full. The range is the money I'd make, which is 0. I could make nothing if nobody showed up to that showing, all the way up to, if I filled that theater, $7,350. Okay, guys, I've been talking a lot, so I'm going to, in a minute, I'm going to stop recording this really quickly here. So hang on a second. So let me stop recording this so I can, if anybody has questions. Let me go over here and hit it because sometimes it doesn't, my little board is not, there we go. So I'm going to stop.